In this demo, I'm going to import a spool that came from AutoCAD Fabrication CAD map. It could also have come from Revit or any other one of the many CAD systems that support PCF export, which is typically coming from the Isogen, SpoolGen packages that are run within or used within the CAD system. So this is the spool that I want to import. We have a run pipe here too. We want to import 4, 6, 9, and 13. By looking at the intersections of these pipes, 4 and 13 onto 2, for example, we want to infer both the set-on type of saddle that we're going to create and the hole that we're going to create on pipe 2. Now in PCF, you're typically, and most CAD systems, you're typically not actually creating the holes in the CAD system. We're creating the holes when we do the import. And that would be for mechanical process work, but for structural work, of course, we wouldn't create the holes. Similarly, we're going to find these OLETs in the PCF file, and because we find them there, we will create holes for those as well. And there's a bit more that goes into OLETs because the hole size for the set-on is often different from the outflow size, but we're not going to cover that in detail in this introductory video. So I will start my importer. We have the ability to set up a bunch of settings here. We have the ability to call preprocessor programs to scrub the data if it needs to be changed in any way. And then we have mappings where you can create a special mapping tool set. We're not going to go into that today. That's pretty in-depth, and usually we do that as something of a service to help a customer get going, though we do have customers building their own mappings as well. It allows you to map data from the PCF file from specific fields into other fields and then do things with them as the data comes in. So I'll select a file here. This is the file that came out of the Fabrication CAD map. So in the PCF file, it found these 5 parts that we have in this drawing: 2, 4, 6, 9, and 13. And we can see they have names here and a few comments here that help identify what they are. Now, not all the data came in out of PCF. In the PCF file, there wasn't any customer data, so we can add that here. So I can add this as company A. I could pick one from a drop-down list as well. That's an easily maintained list. Here I can give it a new job or an existing job. In this case, I just want it to be job AA, just so I can see this once we do the import. So there's a lot more information here that I can add to PipeServer that wasn't in the PCF file itself. Also through mapping, we can bring in more of this data as well, so it's fully automated. There's a lot of extra columns here that you can see and add data to. It just gets a little bit crowded here with this small screen. If you don't want to look at a field, for example, we're not using design group right now, I can just drag that off and I can bring back other fields, and I'm going to grab marking here, or barcode will be fine. And we're going to deal with that in a little bit. We're going to add some data there. Here it's scheduling one part per design part. If you're doing some sort of assembly, you could make it multiple parts. If you're building 3 or 4 of these, you could do 3 or 4 of each. If you're doing a chiller, you could make a whole bunch of certain pieces as well. You can also enter the data right here in each column if you wanted. So if I wanted to find scheduled parts here, I could add numbers here as well to customize how many pieces I want to make. I'll go ahead and import. Now we'll go look at what we've done. We'll go to our job, AA, filter down just to that. And so here's the run pipe with the 3 pieces on it. If I look at the made part here, there's the piece that's connecting onto it. And here's our OLET, little hole there, and the T set on. Now you can further edit this data just by hitting edit and go in and do more if you want. One case that we've had with customers is that they're not sure what the actual set-on size is for the OLED, because the outflow may be an inch, but the inflow could be a little bit bigger, a little bit smaller, or the same. You could do this during importing as well. Just have a verify flag checked here, and that won't let you load this to the machine until the operator actually verifies that cut. And typically in that you would have something looking more like a note here. Okay. And so the user would see that and do their part and get the data finalized. So you have full editability here. You can change all kinds of information, all kinds of metadata, feeds, speeds, lead in, lead out, root gap, all the other things that are standard in Pipe Server. So you haven't been limited by the import. You still have all the power of the cut control. And you could just look at an actual path that you have for this part, and it's animatable. So you can watch the whole thing go around if you want. Go to the next one, go to the next one. Now the next thing I want to cover is what happens if you get a change order. Now we have a lot of customers who've expressed the same pain, is that we've made these spool sheets and they're sitting down at the machine and the person is designing in the takeoffs, and now I've got a change order, so I have to create new spool sheets, walk down to the machine and make sure that the user hasn't already cut them, or if they have, we've got to solve that problem. If we just go back to import, and if the user that's doing the CAD exports the same file, the same data, doesn't go changing a whole bunch of IDs and stuff, they can just make the modifications to the parts. They can come back in and import the same thing. This time it will find that there are parts already in the system. And so just by sitting in their office looking at this data, they can see, hey, it's all green. That means it hasn't been nested or hasn't been cut. They know they're good to go. One of the things, though, if they have a spool sheet that's already down there, that could be problematic. So we do have customers using this field, the spool sheet link, or even the spool sheet name that leads to a link. They can put that data in here and then just update the spool sheet into the folder that this links to, so that they don't have to bring updated spool sheets down to the floor and replace them. So then at the floor, the people doing the cutting or doing the assembly can look up that spool sheet. We also have integrated printing for this, so customers can build their own label print templates, and they can have barcodes for different spool sheet link, project link, in-field assembly link. Different people can go to that label and scan it and pull up the data they need to do their part of the work. In this case, I'm going to do a re-import, and I'm just going to add something to the barcode. Not really barcodes anymore, they're all QR codes, but we work with a company called Nice Label that's integrated into the system. It's a world-class label printing system, and it allows you to lay out any sort of template with any sort of barcode or QR code your systems are using. So this is all set to go. You can see that fed into this column. So now I'll go ahead and do an import. Now what it's doing is it's writing over the existing ones. So I just did an update. Typically this is done in the office. That update happened. They put the new spool sheet link in. They updated the spool sheet, and they're pretty much done because all those parts that they imported were green, meaning they hadn't been cut or anything. So now I can go back and look at this data again, and you can see here now I have that barcode information in here. And I would have any other changes that would have occurred on these parts.